Now you got to pick those chips out. Now you got to get your parts out. Then you got to line up the next parts. You know, it's inevitable that this is going to be a faster machine, any way you look at it.
Hello, my friends. Thank you all for joining us again at MTDCNC. I'm with my buddy Greg at NTL Industries here in Michigan. If it's not obvious enough from the logo behind us or the color of the machine, we're standing in front of a DN Solutions horizontal machine. I wanted Greg to talk a little bit today because he recently upgraded to this machine, this horizontal machining style, because previously he had to do multiple operations on multiple machines, which he's been able to combine here. But we're also going to talk about the importance of chip evacuation with the coolant flush and some of the aspects of horizontal machining itself. So that being said, Greg, let's first start with what was the idea and concept when you said, you know what, I'm going to go from a vertical machining center to a horizontal machining center?
So the main focus was if you had a horizontal tombstone on a third axis vertical machine, you lose out on the Z, right? Because you only have so much movement. So I'm like, okay, well, instead of spending the $50,000 to get an upgraded horizontal pallet system on a vertical, I was like, well, how much do one of these cost? So it's a little bit more expensive to go this route than it would have been going just a regular via a vertical machining center, which we still have. So we can't get rid of those because they all serve their purpose. But at the end of the day, we are able to run just as many parts, if not more parts, with the horizontal machining center than we are with the vertical machining center. And it increases our volume or capacity to what we can run compared to our limitations on our Z height. So if you put all those eggs in a basket and the horsepower that is given with this machine compared to a regular vertical machine, it's a no-brainer.
Greg, that is absolutely right. Now, something else I want to talk about, because that was incredibly good insight for the audience watching right now, because you didn't give up your other machining centers. You've just adapted to another style. Now, by doing so, didn't you combine several operations as well?
Yes, we were running multiple parts on 2 different vertical machining centers, and now we can incorporate that into 1 or 2 operations on this, and we have a done part. So 1, we save on setup and touching time, and 2, it's done at 1 machine compared to 2.
You know, sometimes I'm Captain Obvious on camera, and I think it's important to sometimes be Captain Obvious, because obvious to you might not be to me, and we get to reflect those things. By combining operations, we're doing multiple things, right? We're reducing the potential of setting up a part incorrectly on another machine. We're reducing the potential of not having as good of a finish based on the fact that this is a horizontal machine, but in multiple operations as well. And we're hopefully increasing or reducing our lead time so our customers get the parts quicker, and maybe we can either profit more or they can get a better cost on that. So whatever combination of things go into it, combining operations, and let me not even forget, because you have the floor space you have in this 6,000 square foot building, the real estate we're saving by not having to have 2, 3, 4 machines doing the same process of 1. Is this some of the ideas that went into it as well?
Yes, this was actually going to be another a larger machine, vertical machining center, but I was thinking about, well, if we get the horizontal machine, which we used to run in at my last facility, and the amount of chips that didn't get built up behind the parts, the way the coolant flushed out everything, it was super nice to pick off a part and not get stabbed with chips. So, I mean, the amount of the cleanliness that the chips are able to wash out with coolant, and then you get the through coolant spray with the high pressure feed that we have, everything just works hand in hand, so that way there's no chip buildup and parts come off clean, and then you're on to the next operation. And then if you run the 2 pallets that we do, we run our first operation on pallet 1, we take the pallet 1 and we put it on the second operation, so every pallet that comes out, you actually get done parts. So it's not like you have to store them and then, put them back on. You're actually taking them off pallet 1, putting them on pallet 2, coming out, and they're done.
Would you be able to give me some sort of number, Greg? And I know I wasn't planning to ask you this question, so I'm going to ask it twice to give you time to even think about it. Would you be able to give a percentage of uptime from doing it the old way versus running the product the new way, and being able to switch from side A, side B tombstones, a version of pallet change. I see it switching right now, the tool change as well. Would you say you're at, say, 70, 80, 90% uptime versus 30, 40, 50% before in the different type of environments?
I'd say on a good day, you're probably 85% uptime.
Yep.
Because of the continuous feed rate that you actually get. Compared to a vertical machining center where you have to pause it. Now you got to blow out all the chips. Now you got to pick those chips out. Now you got to get your parts out. Then you got to line up the next parts. You know, it's inevitable that this is going to be a faster machine, any way you look at it. You know, you can always put many different things into play, work holding, how you justifiably pick up a part, you know, how you run a part. And if the fastest way you can get it done is inevitable, better for the customer. So any way you look at it could be, yeah, vertical machine center, that's good, it's been working. Okay, great. But now we take the vertical machine center, tip it on its side, and now we have 3 axes of that part at all times.
That's right.
Plus, we still have our Z length that we have. We have more of a Z length than we do in a vertical machining center, even when we don't have a pallet or vices on a vertical machine center. So a vertical machining center typically is 20 inches. Put your tool offset and everything in like that. Take another 5 inches off, so you're at like 15 inches. This one right here has 34 inches in the Z. Everything that we've looked for in a machine that we can rely on moving forward as we grow as a company is this machine. This machine has the dual contact spindle, so it's very rigid. So, you know, unlike most typical 40 tapered machines, you only have the drive on the taper. Well, this one has the dual contact, or the big Cat 40 spindle that it has. So not only do you have the face mount of the tool, but now you ride off the taper. So it's very rigid, and I wouldn't say it's comparable to a 50 taper, but it's a lot more rigid than a regular 40 taper. So the accuracy that we are able to get on this machine is dynamite. You know, you can run it all day long, all night long. Of course, you're going to have tool wear, just like anything. But the amount of tool wear that you have is decreased substantially due to the dual contact spindle, unlike the regular 40 taper spindle. The accuracy and tolerancing that we can go on here, and we have the probing operation to probe the part before we even pull it out to make sure that we're good before we even pull it out. No one wants to find out, oh crap, now I got to put it back in there on a sawed edge or a raw stock and say, oh, well, that's no good. And if we can't probe it in there with the machine, we'll bring our roller arm over here, or our hexagon 3D scanner, and we'll scan it in the machine to make sure it's not even going anywhere.
I like that you ended with that as well. For everyone watching, this is NTL Industries. And Greg, what does NTL stand for?
Nothing to lose.
Nothing to lose, my friends.
Never too late.
I like that one too. NTLindustries.com. Look them up, Greg. You are amazing, my friend.
Thank you,
Very well
sir.
done.
I appreciate it.